Good evening, everyone, and welcome to Human Factors in Rail. My name is Byron Edwards. I'm pleased tonight to be joined by Sam Waters from the RSSB, Emily Thorne from Atkins, and Richard Bye from Network Rail. Before we begin, I'm aware that we have a range of backgrounds and disciplines on the call, so I wanted to start by giving a quick introduction to the discipline of Human Factors and Ergonomics. On the screen now is the standard definition, and that is the scientific discipline concerned with the understanding of interactions among humans and other elements of the system, the profession that applies this understanding to optimize human well-being and system performance. I'm sure you'll hear a lot more about that application as we continue through the evening. But when we talk about human interactions, that can be further split down into three separate streams. Physical factors, anthropometrics, how people are sized, how big they are, how tall, how far they can reach. Cognitive factors, things such as perception, which colors are more likely to attract attention, which sounds. And then organizational factors, things like how teams work together, how shift work can affect people's performance. That was very brief. That was my elevator pitch as an introduction. And now I'm very pleased to hand over to Sam, who's going to explain a little bit about his role at the RSSB.
Good, thanks very much, Byron. I hope everyone can hear me right nicely. So I guess before kicking off into the main content of my presentation today, I thought it might be worth a quick background on me, so you know a bit about who I am. So as Byron said, and as I've seen on the screen actually, I'm a senior human factors specialist at RSSB. I've worked at RSSB for the past 4 years now, so the rail industry for the past 4 years. And I graduated from Loughborough those 4 years ago, where I studied a degree called Ergonomics, Human Factors Design. So the work that I do day to day very much relates to the information that I gained at university, which is great. So without further ado, just moving on to a bit about RSSB. So who are RSSB? RSSB stands for the Rail Safety and Standards Board. Many of you may well have heard of us before. We were established in 2003 following the disastrous Ladbroke Grove rail crash, where one of the recommendations following this incident was the need for an independent company to provide research and standards for the rest of the industry. We are a membership organisation, so we've got a whole range of different companies who pay in for a membership levy, and as a result they get our information and our expertise. We do a range of different things as well, so we help industry understand risk, maintain the standards, a whole range of different research and development, as well as facilitating collaboration within industry as well through many working groups. So a very quick run through of what RSSB is. Good. So there's a bit of a lag between slides. So just a quick one on the RSSB Human Factors team, because that's what I'm here to present on. We are quite a big team as far as human factors goes, 13 human factors specialists in total. And as I came to create this presentation, I realised we didn't have a group photo, so you're going to have to deal with quite outdated intranet pictures. We have a range of backgrounds, pretty much split 50-50 between ergonomics, so my background, and occupational psychology. So I guess for myself and the ergonomists in the team, we have more expertise in the more physical side of human factors, so anthropometric data, usability tests, whereas the occupational psychologists get more involved in things like non-technical skills and organizational change. So quite a large, diverse team. And just to give you a bit of a snapshot into kind of some of our key areas of work, it would be impossible for me to run through it all because we get involved in quite a bit. thought I'd just run you through kind of some of the main areas that we get involved in. So beginning at fatigue, we've got a number of people on our team who are experts in this area of fatigue. It's quite a hot topic in industry. So we work with industry quite a bit to work on fatigue management, as well as identifying fatigue. Platform train interface, do a lot of work within the PTI as well, so working with dispatchers. I've been involved in a fairly big project recently, which looks to update industries or RSSB's crowd management guidance documentation for station managers, both on trains and at stations. And both fatigue and PTI have their own hubs within RSSB's website. So if you have time after this presentation, after the webinar, please feel free to look at both of them. The Human Factors team also delve into the world of future technologies as well. So we've done a fair amount of work in the area of the European Rail Traffic Management System, ERTMS, a bit of a mouthful, which is basically in-cab signalling. So taking kind of the conventional signals that you see when on trains and putting them within a cab that a driver can use on a screen. And the work there has involved a lot of work with usability trials with drivers to understand if we can make their screen effective and reliable. And we also get involved in a whole range of different trainings as well. So looking at non-technical skills, so the softer skills that industry might have, as well as human factors awareness. And I'm a trainer in the human factors awareness course, so looking at the industry's more systemic picture. So looking beyond the individual and looking to things like the job and workplace factors in the organisation. And then finally, we have a new training around accident investigation. So creating solid human factors recommendations for industry. Good, so that's a bit of a brief run through of who we are and in the human factors team and a bit of our work. Again, cool. So I thought I'd spend the rest of the presentation just talking about two areas of work that I've personally been involved in. The first is very relevant to our current situation, and it's RSSB's COVID-19 response work. Now, my work in this area has been mainly around the revision and understanding of the 2-metre social distancing rule, and really working to do almost a benchmarking activity, looking at the rest of the world and understanding what they've been doing, what other additional controls have been put in place elsewhere that have been effective. So almost kind of like a knowledge literature search in that area. As you can see from some of the illustrative graphs on the screen, 2-metre social distancing is fairly crippling for the industry, running at fairly low capacities. So it's about understanding what other controls can we put in place that reduce, obviously, are safe, but mean that we can reduce this this social distancing rule. And the following slide, I've kind of presented this in a schematic diagram, which is commonly used in human factors. You may well have seen it before, so commonly known as the Swiss cheese model. And each layer of cheese represents a control or a barrier in no particular order at all. And this is all about, I think, more of an illustrative example of how we can prevent the spread of infection from COVID by implementing a number of controls. So each control may well have weaknesses notified by the holes, but it's about putting in controls and barriers to ensure that the risk is reduced and the infection is kept to a minimum. And as part of this, we ran a risk validation workshop where it was really important to have human factors input into that. And we ran the workshop with senior industry bods that basically allowed us to understand and map against a matrix both ease of implementation of different controls as well as effectiveness of implementation as well. And the following slide shows some of those controls that we've identified that other countries have implemented. Now, of course, some, if not most of these controls have major limitations. And so this was a really important step to go through in the workshop to discuss these. And of course, not all of these we upheld to be implemented. But just to take the example of a few which I thought we had quite interesting human factors discussions around, the first two, so things like public awareness campaigns, very easy to implement, but the issues lie in kind of the effectiveness wearing off over time, and even things like the public perception of 2 meters is usually not great. And at the other end of the spectrum, seating layouts on trains, which involves kind of the physical marking of seats, may well be effective to implement by kind of reducing face-to-face contact with people sat opposite each other, but it's really difficult to implement and potentially even harder to control what passengers are doing in that arena. So that provides a very brief and high-level overview of some of the work that we're doing. Again, our website shows kind of that benchmarking activity and maps each control against a passenger's journey in different themes. And the findings of which were really important for us, we were able to take these to the DFT and just use them as an opportunity to discuss this potential reduction in social distance, which has happened. Good. So away from COVID, it wouldn't be a presentation from RSSB without talking about one of our research projects. It's what takes up most of the human factors team's time at RSSB on average. And this one I really wanted to talk about was cognitive underload. I think the official title for this project was identifying and mitigating strategies to mitigate cognitive underload. So a bit of a mouthful of a title. But what is cognitive underload? Underload occurs when workload is too low. It's probably something that we've all experienced before, thinking about potentially driving on motorways, because sometimes work just isn't demanding enough to keep people alert. And in those situations, job performance can suffer. And when we consider this, we can think about things like increased reaction times and an increase in the number of performance errors as well. So you can start to understand why this is a fairly hot topic at the moment for the industry to research, especially as we go towards more autonomous systems. And it's important to note as well that there's been a huge amount of research in the area of overload and high workload, which you can see from the graph. Just a small literature search will show you that. But in the area of underload, it's a fairly not well researched area. So as a result, a lot of this was fairly exploratory research, which was really interesting to be involved in. So this slide we found very useful to present to drivers, because I think we were faced with a bit of resistance from drivers about whether they themselves experience underload. So it was important for us to talk through some of the scenarios where that might take place. So considering things like driving over long routes on green aspects with little going on, for freight drivers particularly being held at red signals for long periods of time with little to do, and then more kind of the intercity operators such as Arriva Rail London driving repetitive routes with little variation, stopping at multiple stations a day. So you can see that underload is fairly varied as well. It's not just the monotony of driving long routes, but it can also be that repetitive nature as well. And then again, we provided drivers with some of the signs of experiencing underload and just talked through kind of whether that was an issue for them. And I wanted to present this slide because a lot of what Human Factors is, especially when approaching research projects, is developing solid, robust methodologies for both data collection and analysis to eventually provide recommendations. And so I think that this project took a good approach that's important to share. So split the project into 2 phases. The first phase involved a literature review, the first step of which was to collect data from other industries. So as I said, it's not that well of a researched topic area, but there is stuff out there. So we collated that and started to build a bank of mitigation techniques that were currently being used. But a really important step was talking to the users, so talking to the frontline staff, the train drivers themselves. And this is where we ran a host of different workshops with the drivers to understand their experience when driving trains of managing low workload, and to understand and validate some of those techniques from the literature review with them, so get their thoughts on them, but also gather any strategies and techniques that they themselves use when driving to prevent themselves from slipping into this state of underload. And we took all findings from that into a validation workshop, which we held with more senior management to understand and validate it, and to understand things like cost, effectiveness, acceptance levels, any limitations of those techniques. And it really was at this stage that we started to identify an important finding in that individuals were very different, and there might not be this one technique, that blanket technique that manages and mitigates underload for everyone. But what we started to find was that drivers were using their own quite novel self-management techniques for underload, but there wasn't this kind of shared repository of these techniques that drivers could use to understand what, I don't know, someone from LNER, a driver from LNER understanding what a driver from GWR was doing. And so this was where we identified this potential toolbox of underload toolbox of different techniques that drivers could use and pick up to understand what other people in similar situations were doing. And this kind of fed into that phase 2, which involved developing the toolbox with a graphic designer and with drivers, but then evaluating the toolbox as well. So not content with just chucking out into industry, we ran evaluation workshops with 2 case study companies to actually understand how effective the findings of the project were, the toolbox was, and to see if we could refine it in any way and develop it and improve it as a result. Now, I don't have time to talk through every single technique in the toolbox. Is around 20. But this is a bit of a snapshot of what the final product looked like, and just pulling out one of the techniques, which involves drivers self-testing on route features. So some drivers who are driving very long monotonous routes would test themselves on features such as level crossing names, place names, etc., just to boost that workload into that optimal state, thinking back to that curve. And we split the toolbox into 4 main sections for each technique. So what is the technique? How do I use it effectively? Why do drivers find it effective? So some of the science behind it, but also what are the risks and the constraints? Thinking back to that finding that everyone's different, one technique doesn't work for everyone. So it's about mixing, matching the techniques to what suits the individuals. And the toolbox includes other techniques such as risk-free commentary, which many of you may well have heard before, to things like keeping the cab environment cool, to even unusual techniques such as singing to keep themselves alert, which we wanted to include for the drivers who might find that effective. I would encourage you after this webinar to look on our website to find this project. So type in on Google RSSB Underload Toolbox, where you'll find a video of the project findings, which probably does a much better job of explaining it than I have. But I think you'll find it really useful as an overview. That's it from me. There's my email address. Feel free to contact me if you have any questions that you think of beyond this webinar. That brings to an end my presentation, so I'll hand back to Byron now.
That's great, Sam. Thank you very much. There is some time for questions now. We've got 1 or 2 coming in. So the first one actually is a question from me, Sam. Obviously, when you go out to end users, sometimes it can be quite difficult to explain what it is that you're trying to get from them. And you mentioned that there's perhaps a little bit of pushback. How did you explain sort of cognitive underload to them, and pitch it so you're not trying to give them more to do or make their jobs harder, but actually trying to help them? I guess what techniques did you use to introduce the topic to the drivers?
Yeah, that's a good question. I think it was about making it relatable. A lot of the briefings that we did we related back to not just driving, but also kind of like I mentioned, driving on a motorway. It's something that we all potentially experience, and it was about kind of tackling the culture as well. So making sure that the wording in the toolbox and the briefings wasn't that kind of you're at fault for experiencing underload, because that is completely wrong, and that potentially would have been quite dangerous to come across. But rather the fact that it's just the nature of the driving task, that things have been designed in such a way that underload is experienced. It's not your fault for experiencing it, but how can we work together, and how can you work with other drivers to manage that and to help other people? So yeah, I think it was about making it relatable to them and making sure we weren't kind of lost in some of the science as well. It was quite important.
Great. Thanks for that. There are some more questions coming through. So I think this one is, what are the performance measures of a top-notch trained driver in terms of obstacles or signage identification and the distance at which they can reliably identify such obstacles / signage?
Sorry, it broke up a tiny bit there, Brian. Could you just repeat?
Sorry, so what are the performance measures of a top-notch trained driver in terms of obstacles or signage identification and the distance at which they can reliably identify such obstacles? I guess how do you measure the performance?
Yeah, it's really tricky. The industry attempts to measure performance through on-train data recording, so almost kind of that black box recorders, and they have certain kind of thresholds, but everyone's performance as a driver is different. People drive trains differently. People have different driving styles, so it is tricky to measure performance as such. But driver managers have kind of thresholds that they mark performance against when it comes to things like reaction times to braking, things like reacting to the automatic warning system, and the on-train data recorder downloads all of that, and it can be flagged to the manager as well. So it's about looking at that and understanding is there any discrepancies to what is common and the norm in the industry.
Great. Another question, this one's from Barnaby Barringer. How do you think the financial impact of COVID will impact TOC investment into human factors technologies, e.g. driver alertness monitoring?
Yeah, good question. It's a tricky one to answer without knowing the future, but I think that when it comes to alertness monitoring, there is a big project going on at RSSB looking into this, that has the involvement of people like the ORR, so the regulator, who are really hot on this when it comes to kind of monitoring performance. So I personally don't believe that it will take much of a hit when it comes to kind of our side. I guess when it comes to the rollout, it might be that financial implications play a part. But if the regulator are the ones that are kind of pushing for a certain kind of monitoring technique, then that's the thing that will drive it when it comes to kind of implementing these monitoring techniques in cabs.
Great. And then one last one for you, Sam. Could the application of the cognitive underload toolbox be extended to other operating grades, including guards, conductors, especially those that work repetitive routes and calling patterns, etc.? Has any work been undertaken on this area? That's from Martin Bonington.
Yeah, great question. I think, yeah, the short answer is yes. It can be, I think, adapted to different roles. Obviously, I think the toolbox in itself is very driver orientated, so there would need to be work done looking at particular roles. But if there was appetite for that within industry, then that's definitely something that we could look into. I think that it's really a really important one to look at for different roles as well. If you think about kind of roles such as signallers who might have little to do, there are probably techniques that they use that to manage their own workload. And as I said before, underload is a relatively new topic area, which I think will become more and more of an issue. And so you'll probably see more and more research in this area. But yeah, great question. I think it can be adapted, and it probably needs to be adapted to other roles as well.
Great. Thank you very much, Sam. I'll let you rest after that one. But there are some questions coming through to the panel, so I might bring you back on at the end as well if you're still around.
Thanks.
Great. Our next speaker is Emily Thorne from Atkins. Hi, Emily.
Hi, Byron.
Over to you.
Great, thanks very much, and thank you, Sam. I'll try and give you now a different perspective of human factors on from a sort of different working environment. I'm going to give you a case study example of ergonomics in engineering projects. So just to give a bit of a background summary, my name is Emily Thorne. I lead a team of 18 human factors professionals within Atkins. And we work not just in rail, we work in nuclear, oil and gas, defence and transportation, including rail projects, providing human factors and ergonomics input to a wide range of complex engineering projects. And the graphic that we've got on screen is something that we use often to share with our internal colleagues, so our engineering disciplines, when we're working on projects, to help explain human factors and the different areas of which it focuses. So we've identified these 5 key elements of a socio-technical system, which is what we focus on to ensure we're optimising human performance for safety and efficiency. So I'll whiz through those quickly, but we would always consider the people, obviously, so the characteristics, capabilities, expectations, the limitations and personal experiences and needs of the people who are going to operate, maintain and support the use of these facilities under the project. We'll also consider the work organisation and culture, so how are people organised, their team structures, responsibilities, working hours and shift schedules. We'll also look at the tasks, so the nature of the work involved in operating, maintaining and supporting the facility, the design of the equipment and technology itself, so including the way the equipment is laid out and the elements that people need to interact with both physically and mentally. And then finally, the working environment, so what environment are people expected to work, including climate, noise, vibration, lighting and other health hazards. So as I said, I'll give you a summary of some of this in action. Focusing on a rail project, a very quick whistle-stop tour of a recent and ongoing project to demonstrate ergonomics in the project lifecycle. So this is the Feltham and Wokingham project, but specifically Shepperton branch, which was the first use of Electrologic's electric interlocking system. So from this first slide, I'm assuming that everybody who has joined the webinar are a bit of a train geek like I am. So you'll have a photo like this. So this is Feltham Area Signal Centre back when it was commissioned in 1974. And you'll see that there are many operators on the control room floor there, but actually when we look back over 25 years or so, the next slide will show the current environment has not changed much at all. Aside from a blue carpet replacing the old brown carpet, much of it is the same. And what the project is looking at is trying to recontrol the Feltham signal box, which is now out of date, to Basingstoke Rail Operating Centre, which is obviously looking forward to the next 25 years. So we need to pay attention to those lessons learned from previous and take them forward. So I'll give another bit of a summary here. The overview shows the area of control of all of the existing signalling panels. So you'll see that there are 4 panel signallers there currently, and they've all got their own area of control, managing the passage of train services across their respective area. So the role and the work environment and tasks of the signaller are really what we were focusing on here. There were other aspects where we also looked at the role of the maintainer. I won't cover that on this today, just focusing on the signaller. And part of the challenge of the project is to manage the safe and efficient operating of the railway while the various stages of the project, which are shown here, so phases 0 through to 5, which is where the different area of the railway will be recontrolled in different parts. So the first part is the Shepperton area, which is shown in grey. It was selected as a trial site. It's essentially a straight up and down piece of track which has a level crossing on it, and was chosen as a trial site for the electrical interlocking. So the first step for our ergonomics work was to conduct a survey. So we've got some visuals here from our taken from our survey report. Essentially, we were having a look at the existing signalling control panel and identifying where are the key aspects of the infrastructure which the signaller is responsible for, and on a task basis, so which of these elements of the infrastructure cause demand or create a task for the signaller to do. What we found through that survey was that actually the area of control is extended during night shifts. You'll see at the bottom part of that slide that actually overnight that we found that they were controlling part of the adjacent panel. So that was an important factor for us to consider in terms of shift management and how we would manage any changes to the interface. The controls the signaller would be looking at is that they had a slightly different shift pattern overnights. So that was an important factor for us to identify. And then zooming in a little bit more, this area shows you the part of the panel that was affected by the project. So by comparison with some other projects, the Shepperton was quite a different one in the fact that it was just affecting an area of control rather than a whole panel. So what this presented was some quite unique challenges, whereby we needed to manage the upgrade and change of this part of the route to a new computer-based signalling control system. The current NX panel, so entry-exit panel, is a push-button control system where the signaller stands and addresses the panel and physically selects the routes that they would like the train to pass through. And our project was integrating a computer-based control system. So key challenges for us were to understand how we would integrate this system in a way that it could still be operated by the same signaller. So I'll take you through some of the steps we first did as we went through this. So the first step was to enable some optioneering, was to get a complete detailed survey of the existing facility and allow us to then go through quite a comprehensive optioneering session with our end users, looking at very detailed layouts for workstation design, so making sure that we'd understood all of the equipment that they needed, coordinating with our signalling and telecoms engineering colleagues to make sure we had space for all of that equipment, and key as well, making sure that we had capacity and therefore future proofing if there were other changes that we thought could be coming around the corner. And then, as I said, embarking on quite an intensive consultation period with end users. This graphic essentially shows two options that were discussed at length in a number of workshops. The first sort of position, you can see that the workstation is positioned to the left of the panel, which makes a lot of sense in signalling terms because the trains make a passage from left to right across the panel. The other location shows the workstation set back from the panel, which had many advantages, being that the signaller would be able to still see the extent of the rest of their control area, which is marked by that blue line that says panel 1. That was very important when we were considering the key locations that the signaller needs to pay attention to and be able to see throughout their shift. So this resulted in quite an in-depth viewing angle analysis to look at the position of the workstation, not just where there was space, but actually what would be the best design to make sure that we weren't introducing errors by making this change to their control environment and HMI. The next step, and really important for all of this, was making sure that we had end users involved throughout. And it's great when you can get some very proactive and involved end users engaged in the process. So we had a very helpful signaller here who actually sat with us on site when we'd marked out the location of the new workstation and sort of visualised himself sitting there. And then on the right-hand side, there's a photo of the workstation actually commissioned, or just prior to commissioning, so a final visit that we did just before everything went live to make sure that it was installed as we expected. So that's a very quick summary with reference to the GRIP stages. Hopefully you're familiar with those, but the Governance for Railway Investment project process for Network Rail is shown there. So we go from sort of an output definition, feasibility, through to detailed design and commissioning. And we did all of those stages on that Shepperton branch. And it was an important step phase 0 for the rest of the Felton project, which is current and ongoing, and we've got ergonomics integration throughout that to make sure that we are managing and optimizing the user interface and experience as best we can and managing safety. So looking ahead, these are the next project stages we need to look at. Phase 1 is coming next, which will take the whole of the area around sort of Richmond to Kingston and including that Shepperton area, and then we'll continue with the rest of the phases over the next 5 years or so as they are recontrolled to Basingstoke Rock. There's some key issues, just to summarise, that we'll be looking at as we go forward. This is obviously presenting quite a change from a standing workstation, standing panel to VDU-based control systems. They've got high levels of automation, and we still need to manage signaler workload, but also there's some very physical environment considerations to manage as well in terms of height adjustable workstations, considering that this is a control environment for the next 25 years. That's a key priority to make sure we can look at those options. Also environmental design, so lighting, ventilation and well-being within a 24/7 control room. I think some of the points that Sam touched on earlier are also very important when we're talking about shared working environments. There's obviously huge value and gains to be had by people working together collaboratively, but we also need to manage the current challenges with that. So we'll be considering that as we progress with regards to social distancing and shared working environments. There's also other issues to manage around level crossings. Level crossings various crossings are due to be closed over the future, but actually some crossings are not feasible to be closed and will be continued to be monitored by a signaler or a level crossing keeper. And those are safety critical tasks that require the signaler or level crossing keeper to monitor the full lowering sequence of that barrier. And in that time, they are completely occupied and need to be not distracted from other things. So we need to make sure that we're managing a risk of task conflict and that other things could come and take their attention away from that key task. Other items on there, as I mentioned, about training. As we look to recontrol to new locations, not all of those staff and operators will be experienced signalers or level crossing keepers. Some of them will be brand new. So there's a big training programme to get in place and make sure the facilities are in place to enable a good and early run up to all of that training. And as I said earlier about the future proofing, making sure that these designs will stand the test of time and have capacity for future changes as best we can. So a few of the just other visuals we would use, so I mentioned about very briefly workload assessment. So similar to what Sam was discussing earlier regarding underload for drivers, underload for controllers is an issue, as is overload. So we will conduct detailed assessments for the signalers to ensure that their tasks are manageable when we're looking at transition from the NX panel to a computer-based control system. And there are going to be many other challenges, as I mentioned, around the physical environment. So we'll continue to develop workstation designs, looking at viewing angles and the volume of equipment that are on workstations. That presents quite a challenge in that you can ask somebody to control more and larger area because equipment and technology allows you to do so, but how much can somebody actually physically look at and see? And we'll be using a range of methods to continue with this assessment. So there's always value in space, I think, for good old paper mock-up. So a photo shown there of a recent example with some end users. But we're also looking at new technologies, including virtual reality. So that's a sort of a screenshot from a fully controllable VR environment that we've created to have a look at the workstation so we can visualize those, which will be useful considering current challenges of getting together to hold workshops. That's everything for me. So if you're there, Byron, I'll hand back to you.
That was great. Thanks, Emily. Some questions have come in for you as well. One actually that was asked right at the end of the last session, but it fit quite nicely into what you just said. So the question is, I've just lost it, apologies. Is cognitive underload / overload something that extends to other areas of the railway, like the control room? What key factors would you need to consider? That's an anonymous question. So maybe a little bit more information about that workload assessment you briefly flashed up.
Yeah, that's great. So that's it is a key area of things that we look at, and it's quite a difficult subject to pin down. I wonder if Richard might talk on some of this later, possibly. But we've essentially we will use a approved toolkit for assessing workload within existing environments, so control room environments, which includes all of the survey data that I sort of shared snapshots on in this, where we'll look at the areas of control that are challenging and difficult, and particular scenarios that might be challenging. For example, there's a lot of focus to be given to possession management and how access to the railway is managed and handed back safely when people are doing work on the track. And as I said, we look at issues to do with task conflicts, so not just how much work is manageable over an hour. We'll actually look at peaks and issues where you might have too many things pulling your attention at once, and the potential for human error where you might miss something due to that overload. The topic of underload is also very interesting, where we've got more automation and the risk that people could be out of the loop, so to speak, because everything's happening automatically, and then as soon as there's an issue they need to step back in and intervene. So yeah, it's a huge broad topic. We could have probably had a whole day just on that.
Great. And another question, and this is from Oliver Craig. He says, do program and project managers, things keep jumping around, do program and project managers see the value of inclusion of human factors expertise throughout a project, or is human factors seen as a box tick within a group spreadsheet?
It's an interesting question. I think it depends. We've got some really good examples where, and as with anything, if you've got relationships and worked with people before and they know the value that it brings, they'll come to you as early as possible. If people are uninformed and do not know a line item in a contract scope or program and it says do ergonomics or right plan, they won't have the experience necessarily to know what it is. So I think it's a challenge for all of us to make sure we communicate clearly about what we need to do and when, and the value that it adds, and the risks and issues that it can avoid if it's not been done too late. But I think generally, for this particular example, that I've walked through here, the challenges of the project were so unique and specific to that environment. It's absolutely not a box ticking activity. It's a working environment for people that are there every day, living and breathing it and fixing the railway when there's a problem. So it's got to be held front and centre for me, and everything we do to help colleagues understand that is all effort well spent.
Great. A question from Simon Kendler. So does increased automation give rise to increased risk of underload, and how might that risk be dealt with?
I think there's more work to do to understand this in practice. There are a number of projects that have recontrolled to VDE-based control workstations. So this example with a signaller, we need to pay real attention to how that automation is programmed and set up in the software to make sure it's useful. So it's not just a broad blanket of what the technology can do. We need to make sure we understand what the user needs it to do. So I think that's a key point. I think there definitely is a risk of underload and what that presents, but really, we've got to do a bit more work to understand some particular case studies and examples to make sure that we're taking that findings into account and feeding them back into projects. I know there's been cases where automation hasn't happened as expected, and actually it means that people are doing more. So it's a fine line, and I think anything we can do that isn't just sort of projects cracking on and instructing a supplier, we need to make sure that those providers of the automated systems are integrated as part of the consultation with end users as well, and we really understand the tasks that the automation is trying to assist.
Great. And one last question. This is from Barnaby Barringer. How do you tend to manage conflicts between end user preferences and industry standards / HF best practice for things like workstation design? Yeah.
I think it's always a contentious issue, and I think as soon as you get to something that's tangible, such as a workstation or a work environment, you'll always get people being very emotive and bringing their ideas to the table because it's something they can see and influence. So I think the best thing is to plan enough time to listen to all of that, and to spend time not just having that discussion about that workstation or that design, but the time spent up front to know where their questions or challenges or ideas are coming from, so you can shape that and take it into account. There'll always be a good place where that sort of perspective or preference is coming from. So I think it's about getting to the background of that as much as you can to know why it might be such a sticking point.
Great. Well, thank you very much for that, Emily.
Super. Thanks, Byron.
Super good. Thank you. Now I'm going to hand over control to Richard By from Network Rail.
I think I'm unmuted now. Is that coming through?
Yeah, brilliant. Thanks, Richard.
Hi. Can you see the screen?
Yes.
Okay. Excellent. Thanks very much, Byron. So, hi, I'm Richard. I'm a member of Network Rail's ergonomics team. First of all, I just want to offer my apologies for not being on a webcam. Unfortunately, a week after lockdown, my laptop broke, so I've had to use the team's very old spare one for the past few months. That said, it's probably not a bad thing, as shortly after my laptop stopped working, I suffered a rather severe lockdown haircut. Courtesy of my girlfriend, who had watched a YouTube video and assured me it was all going to be fine. So anyway, luckily 3 months later, my hair's grown back, although sadly the style or lack of has remained. So that's about as much introduction as I'll do. So the GB Railway is a complex socio-technical system which last year enabled 1.8 billion passenger journeys to be made across the network. And it's a system that's made of lots of different people. And performing lots of tasks and activities. Technologies and equipment to deliver safe performance for the benefit of our passengers and customers. So Human Factors, as Byron introduced at the start, is a systems discipline that's concerned with the interactions between people, processes and technology. The complexity of the railway means that there's a need for human factors throughout the GB rail industry to improve railway system performance for passengers, freight customers and for taxpayers. As such, ergonomics and human factors expertise is an integral part of work at official bodies like RAIB, which is the Rail Accident and Investigation Branch, the ORR, which is the Office of Rail and Road, our regulator, and industry bodies like RSSB, where Sam's from, and throughout the supply chain in companies like Atkins, where Byron and Emily work. And of course, within Network Rail, being the country's infrastructure manager, it's vital for us to have our own in-house team that works right across the organisation. So, how is the discipline of human factors integrated into the railway? The key thing for the ergonomics team at Network Rail is to understand how the railway works. So to explain, and apologies if this feels like we're going back to basics here, but we need to make sense of the whole railway system by looking at its individual components. It's crucial to understand how the railway works and how all the people operating and maintaining the railway and the technology and processes they use interact. And it's by making sense of the railway as a system that we can integrate human factors throughout it. So the performance of the railway is vital to the economy and needs to be safe, secure and sustainable. So what does it take to deliver rail system performance? Well, from a Network Rail perspective, that starts with the timetable. The timetable is a complex balance of supply and demand on a very constrained network. And it's something upon which reputations are built and sometimes knocked down. The provision of the timetable allows trains to run, and this is what delivers the performance for passengers and for freight customers. However, as many of you in the webinar will know, it's not the full picture. So we obviously also need infrastructure that needs to be reliable to deliver the performance that we need. And this is amplified through automation that provides additional speed and capabilities. And to keep everything organized and running smoothly, we need rules, and these inform the processes. And rules specify how work is imagined, and the processes actually describe how work is done. There's sometimes a conflict between the two. So from a human factors perspective, knowing what actually happens on the ground and how that impacts on performance actually is really important. And then the last thing that you need is a bit of know-how. So we'll come back to that, as knowledge, skills and experience are critical to the everyday running of the railway. And they're the only things really that keep the system running when things go wrong and events turn into disruption, as is often the case. So that's the overall system performance. So from a human factors point of view, the whole system approach is fundamental. I've only drawn about 12 purple lines in this sketch, but there's thousands of complex dependencies, and we could probably link every box to each other. And that's really important when considering the principle that the view of the railway system needs to be human-centered. Humans are the central part of the railway system. People are sources of resilience and capacity, responding to complexity and uncertainty in real time to deliver performance and safety. And you'll notice that this is in direct contrast to the old school view of the human as the weakest link, where humans and their variabilities and their fallibilities and error-prone behaviour are the source of all the trouble. But this just isn't true though. Decades of accident and incident analysis have found that for the most of the time, people keep things running safely, securely and sustainably. And by focusing explicitly on the human needs and capabilities at all phases of the system lifecycle, complex socio-technical systems like the railway can run smoothly. And obviously critical to all this is a deep understanding of what is meant by human performance. So I think it is useful just to spend a couple of minutes talking a little bit about what this means. So human performance is a complex field with applied research methods going back to the design of World War II aircraft in the 1940s and the design of factories in the 1950s and train driver cabs back in the 1960s in British Rail Research out of Derby. The scientific literature breaks human performance into a taxonomy of about 1,000 overlapping pieces, but I'll summarise it into a few things in terms of physical senses and capabilities, and cognitive functions and processes, and then the resulting stresses and behaviours. So by breaking human performance down into these pieces, you can understand how to design tasks, systems, jobs and teamwork to make sense and to make the best out of human capabilities and to reduce the opportunities for error. So obviously physical senses are quite straightforward. Capabilities include physical things like speed, accuracy, strength, stamina, reach. So when we're building workstations like Emily was talking about for Felton, for Basingstoke, physical capabilities are quite important. Cognitive functions, attention, perception, vigilance and memory. So obviously Sam was talking about cognitive underload. That's attention and a function of attention and vigilance. And the cognitive processes that fall out of that are things like situation awareness, which is understanding and keeping abreast of what's going on, reasoning and judgments, and the mental models that you form, sort of the picture and the heuristics about how you think the world works, and then the biases that you've got informing the judgments that you make. And then into the mix of all of that, human individual differences and task stresses and pace and other things increase the stress on the individual, and that's in terms of uncertainty or fatigue or negative emotional response, workload, pressure, and all those trigger different types of behaviours around decision making, teamwork, and the opportunities to make slips, lapses and other sorts of errors. So we're really interested in the inputs and outputs of a complex system. but to understand the human performance through that is quite important. So if we understand those human performance attributes, we can use strength and design out vulnerabilities. So as we discussed, from an out-rail human factors point of view, the fundamental principles are to look at the whole system and take a human-centered approach so that the design, operation and maintenance and upgrade of the railway focuses on the human performance required to make the system work. But what does this mean in practice? Well, a principle we've got is to look at context. So we've talked about whole system, we've talked about human performance, and now we're talking about context, because context matters. In fact, context is everything. Because when you view a system from the lens or in the shoes of an individual, person or role, it makes a massive difference. So if we're looking at the rail system from a driver's perspective, the timetable starts to look a bit different, because that's about the pace, the stopping patterns and the train service. The level of automation varies greatly whether you're driving under level 2 in ETCS or whether you're in a degraded mode. The infrastructure makes a difference. So even though at Network Rail we don't design train cabs, but we do design the infrastructure, and we do work out where the lights and the signalling and the other infrastructure goes. So the drivability of the route is a key design feature of our design process. And also you've got rules and processes. So there's the rule book, obviously, and then the procedures and processes for when things go wrong. And then knowledge, skills and experience feed into all sorts of things like how you manage underload, vigilance, defensive driving, and all sorts of other things. So the same goes when you talk about signaller. So the signaler's view of the timetable is a bit different, but it's the same sort of thing. The workload of the signaller depends on the variability and the complexity of the train service. The level of automation makes a massive difference, whether it's a traffic management system, whether there's automatic route setting, whether that's on or off, depending on the mode of operation, how reliable that is, the layout of the infrastructure and the complexity of the junction arrangements, and then all of the experience and skills and knowledge that individual brings to bear on that role. So again, there's a massive variability in just these sort of quite simple railway building blocks in terms of designing the outcomes and the tasks and the jobs of individual end users. And then from a maintainer perspective, same again, the role of a maintainer, a timetable and train service, that depends on whether they'll be able to get access to the track for line blockages or for emergency repair work. The rules and processes about how you get access to site, how you maintain safe separation between trains, how you operate and maintain the railway as technology is increasing. So all of these things make a massive difference. And we could go on, and we work across the industry with, we could have talked about controllers, flight engineers, project managers, when we talk about human factors integration, and all the complexity in the interfaces between all of the roles on the railway. Then actually we need to understand how the system looks to software developers and product manufacturers, as well as engineers and the drivers and the signallers. So, as you may have gathered by now, the scope of human factors work across Network Rail is quite vast. Taking a whole system perspective, we work across the organisation with and alongside colleagues from most areas of the business to provide help, support and advice, along with a bit of elbow grease. Indeed, one of the most satisfying parts of the job is working with all sorts of colleagues, both frontline and backroom staff. And it's really satisfying to see how these disparate roles come together to deliver a working railway. On this slide, you can see just some of our main areas of work. There's a lot of them, so I'll just pull out a few examples, including the specification of standards and requirements, the design of testing, the design and testing of level crossings, and the evaluation of new technology that makes up the railway's Internet of Things. I'll give you a couple more examples and a bit more details over the next few slides. So, a project worked on it back in 2013, specifying the mobile device strategy for frontline staff. 2013 was when iPhones were still relatively new and the first iPads were just coming out. We put in place guidelines, methods, design principles, and produced the first set of mobile apps, and put in place analytics to measure adoption, success, and business benefits. So providing real good early value with the first set of mobile devices for frontline staff. Another example and a project that we're heavily involved in and that have been from near the start is the Digital Railway Programme. From a human factors perspective, this has presented a unique and exciting opportunity as we've been able to integrate human factors from the very start of the architecture and design of the systems. We're writing plans for how human factors will be integrated and managed in all forthcoming digital railway projects. And there's a lot more to say about this, but I'm afraid that's the whole of the presentation in itself. Suffice it to say, digital railway offers an exciting opportunity for future work, and there's more of that to come. And then from the digital to the physical, we are, no pun intended, heavily involved in manual handling. With manufacturers to optimize tasks and to improve equipment to reduce the risk of musculoskeletal disorders. The work's also designed to improve the overall safety and efficiency of maintenance processes. And the team's a key part of the manual handling project that's helped to design many pieces of equipment, including a bespoke backpack you can see on the top right of the screen, and all sorts of other incentives and initiatives to help reduce the risks and the stresses on physical work on trackside. And to cover a few types of work the rail team undertake, I do want to briefly touch on the assurance work. That's what connects our team with the work that at Atkins and that Emily and Byron work in. So several members of our team work as assurance managers. So for the Felton project that Emily talked about, a member of our team worked on the project as the assurance manager, looking at standards compliance and managing the overall safety and performance risks of the project. And our work covers a lot of signalling projects, as well as the design and upgrade of stations, new control systems, upgrades to existing technology, and so on. So looking to the future, there's an awful lot to keep the team busy with an ever-increasing demand for our input into a whole range of projects and initiatives. Digital Railway will become an increasingly important part of our portfolio of work. And whilst we'll continue with all of our core activities over the rest of this control period, we've got an explicit focus on the production of new standards and requirements, as well as looking at the development of new tools and techniques for the measurement and management of human performance. And with that,
That's great. Thank you, Richard. We'll go straight into questions if you're still there.
Yeah.
Great. So first one, what aspects can be influenced in terms of drivability of a route? Must be challenging with so many fixed assets and structures such as stations, platforms, bridges, etc. That's from Simon Kendler.
Yes, so obviously signal sighting is the main thing. Making sure that there's enough distance, enough clarity and visibility. I think as Sam mentioned at the start, Ladbroke Grove and other major accidents in the past were due to signal path danger, which is read across to signals and other things. So it's mainly making sure that signalers need to understand where they can stop and trains in a safe place. So we had an incident in Southern, just outside Lewisham Station last summer, I think, or really quite recently, where we stopped a train outside the station. But if passengers can see the station and it's hot and they're there for a long time, there's the potential for them to want to try and exit the train and walk the rest of the way, which obviously isn't a very good thing to do. So there's all sorts of interacting features, but the main thing around signalling design is the infrastructure layout and the position of the signals.
Great, thanks for that, Richard. Another one then, you've mentioned quite a few technologies, digital rail, etc., which is right at the cutting edge and producing standards for those. Where do you find the information for that? Do you commission research? Is there learning from other networks around the world?
We do all of the above. So I mean, a lot of the technology that is that forms digital railway, which is basically ETCS, traffic management, CDAS, with some ATO on the top, is proven technology that's been around for quite a while. The difficult thing about digital railway is the integration of the technology with other systems and with the people and processes that need to make it work. So we've been involved as an internal network rail ergonomics team since the very start of digital railway program type implementations, going back to before it was called digital railway on Cambrian. I've personally worked on every traffic management system that's gone. So we've done a lot of learning the hard way before we're writing things into standards. But also, you know, I had a conversation yesterday morning with some with the team from New South Wales who are implementing traffic management, talking about our approaches and what they were doing. So lots of learning across you know, globally, and then best practice from. So when I wrote the management plan, it brought into bear the best of sort of human factors integration that we've done on the railway for the past few years, but also looked across, and I've been speaking to people who work in aviation, people who work at NASA, military, all sorts of other domains, to make sure that there wasn't anything useful that we hadn't captured. So some of it is iterative, that we're built on for over quite a long years of practice. Another of it is just trial and error. So I think there's a lot of work to come. I think we've got a really good baseline to go from now, but then it's the next phase now on East Coast and Northern traffic management are the big projects that will start to really release the benefits, I hope.
Great, thanks for that, Richard. Okay, I'd like to invite Emily and Sam back onto the line. There's just a couple of panel questions, and then everybody will be able to go off and have their tea. Great. So Richard almost alluded to that, but a question from Oliver Craig. How does the study and implementation of human factors solutions in the rail industry compare to that of other industries? I guess an open floor.
I guess from a perspective of working on other high hazard industries, it's quite similar in the fact that there is a regulatory aspect to it, and there are standards and assurance processes we need to work to, and anywhere in a system there is a person somewhere where you've got high levels of automation or not as very manual tasks. So the processes that we need to follow are similar in that aspect, and understanding, you know, what options are available, screening those out, developing detail, and you know, getting end user input to that is central to it. But there are a sort of a range of standards and methods of how those control measures sort of put in place within a particular stage gates. I don't know if that answers part of the question.
Yeah, I think so. Richard, did you have anything to add from the benchmarking of NASA and the like?
I think that I think a mature systems engineering approach is beneficial on a lot of projects, but we've also got an awful lot of variability. So we have to tailor our requirements and our processes to meet the needs of the context in which we're making the change. So we don't need to go through full human error analysis for a very small change in a lever frame box, potentially. So there's things consistent with lots of domains where we'll do an early risk assessment and early human factors analysis and work out what we need to do, and then pull in the right and best methods that are appropriate. So we're learning from lots of work in aviation around things like measuring brain activity and gaze as markers of physiological fatigue and workload. Some of that's more difficult with tasks that we've got. So there's definitely things that we can learn, but also things that other industries learn from the rail industry. I've done quite a lot of work with maritime and other organisations, so that there's quite a lot of transferable work.
Great. And then one final question on career pathways. Someone's asked, do you need a degree in human factors for a career in ergonomics and human factors? Or what other ways are there into the industry? And that's for everyone. Did anyone not go to Loughborough?
I didn't go to Loughborough.
Oh, there we go.
And I think there's loads of ways in. I'll give a quick answer, then I'll let you have you go in, Sam. I think as well with the Chartered Institute of Ergonomics and Human Factors, there's a lot of work now to open up sort of technical grades into membership. So learning on the job. I think a knowledge of the fundamentals is really important. But for the work that we do, you need to understand the technical human factors and ergonomics work, but you also need to understand the railway. And those two things together are quite important. So, I mean, if anybody wants to have a discussion about sort of career entry and other things, then I'm more than happy to share my email address. But yeah, I think there are lots of ways in. I think if you're keen and if you see problems from a psychologist or a human factors point of view, I think then there's a lot of really interesting work and really potentially interesting and promising career paths.
Yeah, and I think the CIEHF website's a good place to start on this as well. There's a great section on there about kind of career opportunities, accredited courses, that kind of thing. And just going back to my presentation, half our team has degrees in psychology with kind of a master's in occupational psychology. So it's not that you need a degree in ergonomics and factors to go into it. As Richard said, there's a range of different ways in.
Yeah, I would agree that just to sort of close the loop on that. We've had examples on projects where you might get engineers saying, I've come up with this idea, am I thinking of the right kind of thing? And actually, just because it doesn't have a sort of human factors or ergonomics badge on it, they're doing it through projects anyway, based on their experience. And whether that might not be a rail example, but say there's something that's been built on site and somebody can't reach it or access it in the way that they expected, or something else has been installed alongside it. Often optioneering to try and move some of those barriers and make somebody's life easier is starting on that step, on that journey. So I think we often come across it through projects anyway. And then it's about understanding, have we got the right level of rigor and competency to make sure that we're covering all the eventualities? And that's where some additional training and background and experience comes in. I perhaps sort of reference that Sam mentioned that there's lots of information on the IEHF website. There's specifically on there, I think an online course offered by Derby University and MSc, which is worth having a look at, particularly now it's offered online, so we can't get to places currently, so that might be something that people are interested to have a look at.
Absolutely. Well, that's all the questions we have for this evening. So all that's left for me is to thank all of our speakers. I found it very interesting, and I hope everyone on the call has done too. So thank you all very much. Just wanted also to point out that we have an event tomorrow night. It's another webinar. It's To My Future Self. It's a careers event with senior people in the rail industry, giving the advice that they would have liked to have heard when they were just starting out. And that's a really good series of events to join in on. So thank you all for listening. Thank you again for presenting, Emily, Sam and Richard. Have a nice evening.
Yeah, thanks, Brian. I'd just like to say thank you for organising it. Really appreciate the opportunity.
Thanks, everyone.
Absolutely. Take care.